Okay, so this is the walkthrough for assignment 4. And for this assignment, we're going to create a loan amortization calculator. An amortization schedule is a breakdown of loan payments that shows how much of each payment is going towards the interest and the principal of the loan, and usually what the remaining balance is after that. So there are a couple of things in the instructions to pay attention to. First of all, it warns you to make sure you format the output like currency, and it also warns you about using math.round in order to avoid perpetuating rounding errors throughout the months. At first, the first few months will look okay if you don't do this, but then eventually you'll see you'll be off by a few cents towards the end. So we'll use math.round to avoid that. Basically, there are three parts to this. The first part is we're going to gather the information, what the total loan amount is, the interest rate, and monthly payment amount. Then we're going to calculate the amortization schedule using the formulas provided here. And then we will print a summary at the end showing the total amount paid, total interest, and total number of months. So to get started, we'll just go ahead and add some comments here to remind us what we're doing. Select information, calculate amortization schedule, and then print summary. Maybe instead of calculate, we could say generate, since we're going to be doing calculations and printing some output. So again, totally optional to do this, but it helps to take a bigger problem, break it down into smaller pieces. So we will ask three questions in this program, and I'm going to use the same write prompt method that we used in the assignment 3 walkthrough rather than using write line, so that we can match the spec here and let the user enter the values on the same line as the question. So we'll call this the amount input, read that line, and then we'll convert that. We could use float or double or decimal just like before, but since we're dealing with money and this is C sharp, we use decimal. Other languages don't have the decimal type. You'd probably use float or double, but in our case, we'll use decimal. So we'll say the amount is going to be equal to convert to decimal amount input. That's our first prompt. Our second prompt is going to be, what is your interest rate? And we'll call that the APR, the annual percentage rate. And we'll read that from the user. And then we'll convert that. Notice the pattern here. We have our strings named whatever input, and then that allows us to use the actual name for the final value. So amount input, then amount, APR input, then APR. So it's really clear when we follow patterns what different variables represent. Right, and our final question is, what is the monthly payment? And we will select that also into a string and convert it to a decimal convert, just like we've done before. So you'll notice as you go through this course and other programming courses that programming is a lot about pattern matching. We learned the pattern for collecting input and converting it to a type, and we reuse that pattern over and over again. So we don't have to relearn that, rethink, how do I solve this problem every time? That's why it's so important to take a big problem, break it down into small pieces. Some pieces we already know how to solve, others we have to figure out as we go. So those are our three pieces of information we need for this program. And now we're going to generate the amortization schedule. And we have learned about four different loop types: for each, for, while, and do while. Technically, with the exception of for each, which is a little specialized, you can solve any loop problem with any loop structure. But some loop structures are better suited to some problems than others. So in this case, we're going to use a while loop. Now, we want to execute this loop for every month that we still owe money. So what we'll do is we'll create another variable here. We'll call it current balance. And to start with, we will set it equal to the loan amount. And throughout the loop, we're going to deduct from that current balance. And we'll say while our current balance is greater than 0. Then we will have our loop, and within our loop, we need to do a few calculations. Now, this first calculation, determine the monthly interest rate. This is going to be the same interest rate every month. So we're going to calculate that before our loop begins. So we'll have monthly rate, and we'll be explicit here, even though it's a little long. Monthly interest rate is going to be equal to our APR, which is our annual percentage rate, divided by 12, so that that's per month, and then divided by 100. And we're dividing, those m's mean decimal constants. If we were floats, they'd be f, float constants. So that dividing it by 12 gives us the monthly rate, and then dividing it by 100 turns it from a percentage into a decimal, which is what we need. So now that we have those two pieces of information, we can begin our loop. And for our loop, we're going to first calculate the interest for the current month. And so we'll say monthly interest, and we'll call this monthly interest amount to differentiate it from monthly interest rate. And that is going to be equal to our current balance multiplied by our rate. Now, I'm going to do this slightly wrong at first so we can see how it goes wrong, and then we will fix it after that. Okay, so now we'll move on to the next step, calculate the principal paid for the current month by subtracting the interest from step 2 from the payment. So now that we have the monthly interest amount, we'll calculate the principal in step 3. The principal is just whatever we have left over from the payment after covering the interest. So to calculate that, create another variable, monthly principal amount is going to be equal to our payment minus our interest amount. Okay. And then finally, we will calculate the new balance at the end of the month after the payment's been applied, and that will be based on the current balance. So our new current balance is going to be equal to whatever the balance was before, plus the interest that we incur, minus our payment. So that's our new current balance. And now let's just print out our line. Now, there's one piece of information we're missing here. If you look at the output in the example, we have a month index or a month number, and we don't have that. So we'll go ahead and create a month counter, set it equal to 1 to start out with. And then inside of here, we'll start by printing the month counter. And then for now, we'll just print everything out, make sure our calculations are fine. They won't be, but we will fix that. So we have our monthly interest amount, and then our monthly principal amount, and then our new balance afterwards. Then at the end, we need to make sure we increment our month counter. So we'll say month counter plus plus. That will take whatever the current value is and add 1 to it. Okay, so that's our loop. It will keep going as long as our current balance is greater than 0. So we'll run this. We're going to have a few problems, but that's okay. For that to compile, and we use our test amounts, 21,000, interest rate of 4.5%, payment of 350. Now, you'll notice we've got some really big numbers here, first of all, and we'll fix that in a minute. And you'll also notice that we've got a problem where our last month is a credit balance. We don't want that. But we also notice that our next to last month, $34.45, does not match the example. And that's because we have rounding errors that are perpetuating slowly through building up until they become noticeable. And so the first few months match exactly, and then eventually we're off by a penny, then 2 cents, then 3 cents, and 4 cents. So let's fix all of these problems. First, let's fix the formatting. So to do that, we're just going to use our format specifiers to convert all of these to the localized currency format. That'll make everything easier to see. So let's run that again. And 21,000, 4.5, 350. And so now everything looks better, but we're still in our first few months are correct, but eventually we're off until we're off by a significant amount. So to fix that problem, the instructions give us the clue here. make sure you use math.round to prevent rounding errors. This is really the only place we need to do it. So let's go ahead and do it here. We will say math.round, and we're going to round that calculation to 2 decimal places. So what this math.round does is it says take whatever value is here, and in this case, that value is going to be whatever the balance is times the interest rate, round it to 2 decimal places. The result's going to get stored here. So if we make that one change, put in our input values, you'll see that we now end up with $34.50, just like we should. This is the only place we need to do that because this is the only place where we're doing multiplication or division. All the addition and subtraction is going to be just fine after that because we've already rounded. So whenever you're working with floating point numbers, whether it's decimal, float, or double, always pay attention to rounding errors. Sometimes you'll want that rounding to perpetuate, and you'll want those extra cents in there. But in this case, the problem statement says we want to round to 2 cents. This is our verification. Now, what's interesting is you'll see other mortgage calculators. For example, if you look at this mortgage calculator online with the same amount, if you look, the bottom next to last month is 34.45, which is what we had before we rounded. So you'll see different implementations of this amortization algorithm in the wild. And so it's important to know what exactly what we call the business rule is for how to handle decimal cents. And in this case, according to this business rule, we're going to round to the nearest cent. All right. So our next problem that we are going to deal with is our special case at the bottom. So we really have 2 problems we need to fix here. The first is that our payment amount should never be more, our principal amount rather, should never be more than our current balance. The second problem is our final balance should never go below 0. So we can fix both of those problems using a technique called clamping. Clamping says that if a value you're calculating goes above or below a certain threshold, you can clamp it or move it back to that threshold. So for example, if the balance ever goes below 0, we set the balance to 0. If our principal amount ever goes above what we owe, we clamp it to what we owe. So we'll see an example of that here. So we're going to do 2 calculations. So there are a bunch of ways we could do this, and they all have trade-offs, but we're going to do it a simple way. We're going to say if our monthly principal amount is more than what we owe, then we know we are on the last month. And so in that case, we will say that our monthly principal amount is now going to be equal to our current balance, and we're going to set our current balance equal to 0. Otherwise, we are going to do our calculation just like we normally did. So let's review this. This case handles our last month. The case says if we are trying to apply more than we owe to the loan, then it's time to set the applied payment equal to the balance and set the balance equal to 0. Otherwise, we're going to do our normal balance calculation. Then we're going to print everything out. So let's see that in action. 21,000, 4.5, 350 payment. And we can see that everything then works out the way we want. So now there are 3 things left to do: our column headers, our alignment, and our summary row. So we'll go ahead and do column headers first. So before we execute our loop, we will print out the month, interest, principal. Technically principal spelled this way, so we're going to do that. And then it looks like we've got 1, 2, 3, 4 spaces, 1, 2, 3, 4, and then balance. Now we can't use alignment specifiers easily here because there are no variables. So we're just going to do that. All right, so now let's go down here and print our summary. So our summary is going to be relatively easy once we calculate everything we need. So our total paid, need to calculate. And to get our total paid here within the loop, every time, there are a bunch of ways we could do this one. But the easiest way is going to be before the loop starts, we will create a total paid variable. And then we will create a total interest variable. And we already have our month counter. All right, so to calculate the total paid each month, There are a couple ways we could do it. The easiest way is just down here at the bottom of the loop, say that total paid is equal to, you may be tempted to say something like this: total paid is equal to total paid plus payment. But if you do that, you will be off by the difference in the last month. So instead, if you say total paid is equal to total paid plus whatever we paid for interest plus whatever we paid for the principal. Because remember, on our last month, we do the principal calculation differently, and so that will all work out. Now, a shortcut here is, instead of writing this, is to write plus equals, which says the same thing. Take whatever total paid was before, add this to it, and then set that value back in the total paid variable. So let's make sure that that matches what we expect before we go any further. So we'll add that to our format string. 21,000, 4.5, 350. Total paid 23,834.63. That looks great. Except we do need to format it as money. We'll do that. All right, total interest, we can do the same way. Just here at the bottom of the month, total interest plus equals monthly interest amount. And we will just add this here, total interest. Now it looks like in the output, they actually have a period after that. We'll copy that same format. Total interest, also formatted as money, period. And then months, we already have that calculated. Our final month will just be whatever our month counter gets set to, -1. That's important because when we get to the end of month 69, we've done these calculations, we're going to change it to month 70, come back to the top of the loop, and our current balance will then be less than or equal to 0, so we will exit the loop. So since our month counter will be 70, but we've only got 69 months, we have to subtract 1 before we print that out. So we'll see that running here to make sure we have that right. 4.5, 350, and looks like all of our calculations are correct. So our last step then is to work on our alignment. So to do this, we again just need to think through how wide do we want each column and how do we want it aligned. So our first column, month, is going to be 5 characters wide. 1, 2, 3, 4, 5. So let's go ahead and find that output, and we'll say month counter 5 for our alignment. Let's run that, and when we do, you will notice that we have our month is aligned to a 5 character long column, and we are aligned to the right because that's the default alignment. So now our interest rate column, we're going to start counting right here, very top. We're going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's the width of our interest rate column because we want everything to line up with the T. So we'll just say monthly interest amount, comma 11. That, and you'll see that when we do, so when we do this, you'll see we're off by 1. And the reason for that is because we have a space already here. So since we can either get rid of this space or we can just subtract 1 from this. We'll just subtract 1 for that and rerun that. And 21,000, 4.5, 350. And now that should all be lined up properly. And we'll do the same thing for principal. So we've got a space that we printed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. In this case, it should be 11. We'll run that, make sure that column works. Notice that we just test each column as we go, rather than just putting in a bunch of values and then trying to figure out what is throwing things off. So we just, from left to right, just align the columns. And then our balance, so that looks good. And then our final column is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 wide. So we'll just plug that in here. On that program, 5, 350. And then our output is all aligned properly. Okay. We have our total paid and all of that. All right. So just review a couple of things here. Key point, we broke up our program into steps. Step one, collect information. Step two, generate amortization schedule. Step three, print the summary. We solved the first step, then we solved the second step, and then the third step, and then we went back and worried about formatting. So that's a good rule of thumb because, again, as the assignment mentioned, for this particular assignment, we didn't take a lot of points off for alignment. I took a couple off, but then gave people the chance to resubmit, and hopefully everyone will do that. So you always want to tackle the most important parts first. And so in this case, that was the calculations. Also, we used math.round to do the amortization calculation for the interest rate, because otherwise we will end up with rounding errors that will perpetuate through the numbers and generate incorrect values at the end. So I want to emphasize again that that is a business rule. This problem said we are going to always calculate based on rounding to two decimal places. Other calculators, other financial transactions may say no. We actually want to take into account the third, fourth, or fifth decimal place or be as precise as our software will allow us to be. And so we are not going to round until the very end when we display the value. Both can be correct. It just depends on the business rule. So you can see this calculator, again, uses the different approach of not rounding this calculation. The other thing to point out here is how we handle the alignment. This is something that is still gives a lot of people trouble. Start with the leftmost column, get that alignment working first, test it, then the next column, then the next column, then the next column. Watch out for spaces like we had here, which will throw off your counts. Make sure you're formatting correctly. Make sure you have the baseline. If you have the column headers first, you'll know if your alignments are working out or not. And then the other thing is if we have a variable that we need to do something within the loop and then print the results of that or use those results after the loop is over, we have to declare those variables before the loop begins. Okay? So as always, if you have any questions, be sure to ask on Slack or send me an email.